Okay, welcome back, Matadors. We're getting into Chapter 2, Lesson 3 on reflections. I want you to think of what you see when you look into the mirror. That's a reflection, and that's the same thing you're going to do in this lesson, but from a mathematical standpoint. So here's our essential question. How can you use reflections to classify a freeze pattern? Well, before we get there, I just want you to take a look at this image here up on the screen. You have a sunrise in some nature region, and if you look, the red line indicates what's called an axis, and it's basically the line that indicates to you that you are looking at a reflection from the actual sky, right, in the actual setting, as opposed to its reflection over a lake or a body of water. So the water is performing a reflection of the top section of this image, and the axis is indicating where the top section or the actual sunset or sunrise is, and where its reflection is along the body of water. So that axis serves as a line of reflection for the actual mountain and the reflection of the mountain. Okay, moving on. Now this is a freeze pattern. So a freeze pattern is usually some type of design that's towards the top of either a building or maybe towards a ceiling, above a door. It's called a freeze pattern, and the way that you generate freeze patterns is by using a technique called reflection. So this is a freeze pattern here, and if you look all along the top section of the freeze pattern, it's the exact same as if you were to direct your attention to the bottom portion of the freeze pattern. Okay, the way you can generate something like that is through what's called a reflection, and that's indicated here in this image. If you look at the red dashed line here, that indicates to you that it's the top half of the freeze pattern is exactly the same as the bottom. So this is called a reflection. So you can make a reflection to design a freeze pattern, and you can take this with you into computer graphics when you're trying to make a logo for a sports team or for a class or for a t-shirt. Whatever you do on one side, you can get it exactly the same on the other side by performing a reflection. So let's go ahead and take a look here. The key word I want you to note is flip. So reflections can be described as a flip. Okay, and if you look to the right, there's somebody flipping, so hopefully you won't forget that you want to use the word flip when you're describing a reflection. A reflection happens over what's called a line of reflection. So over what's called a line of reflection. So you can reflect a shape over the x-axis or over the y-axis. A reflection creates what's called a mirror image, right? A mirror image, just like you saw in the picture before of the sunrise in a mountain area. A reflection creates a mirror image of the original figure. So looking at these two images that you see here on the left-hand side, in pink you have what's called the line of reflection. Since it's going vertically, we can assume that that's the y-axis, right? And on the left you have the pre-image. This is again, we're going to use a right trapezoid. And on the right you have the image, the mirror image, right? And if you look, every point was flipped right over to the other side of the axis. It was flipped over to the other side of the axis. So that's what you call a reflection. Okay, the red image was reflected across the line of reflection, right? It was reflected over the line of reflection to its mirror image, exactly the same on the other end, on the other side of the line of reflection. Let's take a look inside this black box here. You have two figures. Is that a reflection? Yes or no? Well, the answer is no. This is not a reflection. Why? Well, if you look at these two shapes here, they look like arrowheads, right? And if you notice, the arrowheads remain pointing in the same direction at all times. So they were not flipped over the line of reflection. They were not flipped over that pink line, the y-axis. They were actually slid, right? This was like a slide. So this inside the black box is a translation, right? Not a reflection. So on the left, you have your reflection. On the right, it was kind of a quick review so you can see the difference between a translation, which you learned in the last lesson, and a reflection, what we're going over right now. So now here's our last example. This is a key idea taken from the Big Ideas math book. Real quick, this image here, the red image here in the upper left-hand corner, that's going to be our base image. That's what we're going to use to basically perform two reflections. So that's what we're going to start for both of the examples that we're going to review with this figure here. So to reflect a figure in the x-axis, you take the opposite of the y. So if you're reflecting over the x-axis, you take the opposite coordinate of the y. So real quick, what are opposite numbers? Okay, what are opposite numbers? Think about that for a moment. What are opposite numbers? Okay. To reflect a figure in the y-axis, so now we're looking here, you take the opposite of the x-coordinate. So when you're flipping an image over the x, you flip the y. When you are flipping an image over the y, you flip the x. And that's indicated here. So reflecting over the x-axis, you take your y and you write its opposite. So if it's a positive y, it becomes a negative y. If it's a negative y, it becomes a positive y. Same thing if you're reflecting over the x-axis, if you're reflecting over the y-axis, you take the x and you write the opposite of the x. So if it's a positive x, it becomes a negative x. If it's a negative x, it becomes a positive x. So let's take a look again. We're going to focus here on the red triangle here. We're going to focus here, and we're going to use point B as a starting point, as a point of reference that we can use to kind of illustrate what we're talking about when we're flipping a shape over either axis. So let's go ahead and take a look at point B. And what we're going to do is we're going to reflect that triangle over the x-axis. So since we're flipping it over the x-axis, we're going to have to make sure that we flip the y-coordinate of that B. So what is the coordinate of B? Let's find the ordered pair of B. Well, B is located at negative 1, 2, 3, 4. So negative 4 and positive 1, 2, 3, 4. Positive 4. So B is at negative 4, positive 4. Okay? And we're going to use that right here. So B is at negative 4, positive 4. So if we're reflecting it across the x-axis, we're going to change the y to its opposite. So what is the y? It's a positive 4. What is it going to be when we perform our reflection over the x-axis? Well, if you look here, it's at a negative 1, 2, 3, 4. So it is now at a negative 4. So we just took the opposite of a positive 4. Okay? And again, you can rewind this and watch this again if you need additional support. Now we're going to use this same B of this red triangle, and we're going to now reflect it over the y-axis. So we're going to flip it over the y-axis. Okay? So since we're reflecting over the y-axis, we're going to want to flip the x-coordinate of B. So we know the coordinate is at -4, +4. Since we're flipping it over the y, we're going to want to flip the x. We're going to want to flip the x to its opposite. So what is the opposite of a -4? Well, it's a +4. And you can check that here. 1, 2, 3, 4. I'm sorry. 1, 2, 3, 4. 1, 2, 3, 4. Same thing, but in the opposite direction. Right? 1, 2, 3, 4. And then it was 1, 2, 3, 4 in the opposite direction. Okay, so you can see that all you need to do to perform a reflection is just flip the opposite coordinate to its opposite number. Thank you for